Hello, everyone. Welcome to the last day of GDV. So today will be pretty open-ended. We're just going to be answering any questions that you have during this last week. I'm going to actually show my video real quick so that we can see everyone. Hi. And we'll also pull that up. So how's everybody doing today? Feel free to post in chat or unmute yourself and ask any questions that you have about any of the materials that we've gone over, whether it's sneaky or any of the week 4 materials. I'd be more than happy to point you in the right direction. Any questions?
My only real question is, what do you think is the best way to handle like a stacking state machine?
So there's a couple of different ways you can handle stacking state machines. If you're talking about like a state machine for menus being stacked and things like that, when you refer to a stacked state machine, that typically means the one that was just pushed onto the stack the last. That is the one that gets updated, and then you have the easy ability of like just popping off that state so that the next thing on that state or on the state machine set as active will run. That's typically for menus and things when you pull up, for example, what am I thinking of? If you have menus, yeah. So let's say you're in a main menu, you press options, that'll push the options menu onto the stack. Let's say you have a graphics options specific menu, then you press graphics options, that's going to push that onto the stack. And then anytime you exit that current version, like this is the graphics menu, we're going to pop off that state, and then this state, which is our options menu, will just currently run. We can pop that back off, and then we're at our main menu again. So you typically do updates on that just for the current state. If you are talking about a behavior state machine, such as like which script will be running or something like that, it varies on how you need it to work. If you have active abilities that all need to be updating at the same time, you would typically have like an array of those different active abilities and activate them. So you can add this as an active, add this as an active, and just those active abilities would run. And then they just get removed after they're done and go to a default idle state or something after if all of them get removed. Is that what you were kind of asking?
Yeah. I was curious as to like the UI state machine usually takes input, right? That is affecting the data within the UI, and that's
Yep.
something I had thought of maybe 2 days ago. So I thought, well, that would have to function differently than a behavioral stacking state machine, because the behavioral, even though you're giving input, you're not really changing the state like you do with the UI, right? Because they're going to change settings and change variables in the UI, but if they're just jumping, shooting, attacking, etc., in the behavior state machine, the behavior state machine pretty much just stays what it is. So it's a matter of activating each one of those states and making sure that the hierarchy functions without things overriding or interrupting what each other state's supposed to be doing.
Yep, and that's where those transitions come in, because they're only one-way transitions. What is my current state that I'm in? What can I transition to out of here? What code do I need to actually check for input for this specific state?
Yeah, that's kind of what I was wondering. So thank you.
Adrian and John, did you have any questions about it? Any of the sneaky stuff? Oh, here we go. All right. What do you think is the best way to set up the guard aggro? Big issue you face, putting a trigger on the guard. So we could actually walk through that real quick. Okay. So let's take a look at it. So here we just have our nav agent and a manager, which we left off from the last one. Our last thing we were doing was setting up the lights, demonstrating the different overloaded behaviors for a light. Oh, and it cuts out. Hopefully I'll be back soon. There we go. Okay, so let's take a look at how we could set up an aggro for this. If you watch the other videos, you know that you can set up some sort of distance around our character or collision around our character to tell our agents to aggro. And I got to close out of some of this stuff so I can actually see Unity. So in our player, we'll go ahead and add another collision to this. So we already have our capsule collider. I'm going to add another collider on this. Well, let's actually add it to a sub-object of this so that it can be separate and have its own script rather than throwing everything into the player script. We'll call this aggro object, or just aggro. And then we need to add a script to it. I'm going to add another script. Aggro. I also want to make sure that, oh no, why is it lagging? There we go. That we add some sort of collider on here. And we'll just do a sphere. That's going to be our simple one. Make it a trigger so that it's not ridiculous. And we will change the size. Let's say it's going to aggro everything in a 5 unit is pretty big. See, that's about a quarter of one of these rooms. Let's make it a little bit smaller at 3. All right. We then want to make sure that our aggro script is attached to our aggro object. And we got to tell that script what to do. All right. So for the script, we'll just handle on trigger enter, and on trigger exit. We then need a way to tell our agents or our guards that are walking around to actually start following the character or start chasing our player. So we'll set up that state on our agents themselves so that we have something to call when one of the agents walks into our player's aggro radius. So we'll go to the nav agent state machine best script. That is our guard script. And we will need to add another state to this. I'm going to just copy the pause state so that we have something to work with. And we're going to call this aggro state. When we enter it, I'm going to set it to, I believe the color was magenta. And now that we have that state, we want to make sure to add it to the state machine because we've just created the class. Add state. Aggro state. And then just like our pause function, as well as our toggle selected function, we need a helper function to track whether we are aggroing or not. So we'll create another bool for is aggro. And we'll set that to false. We don't want it to start out aggroing. Then we need to create a function. We want to call this outside of this class, so we will make it public. Don't need to return anything. we'll just say toggle aggro. We'll toggle the bool. And then we need to tell it to change to the aggro state if it is aggroed. So if it is aggro, otherwise, and we can just keep this one line so we don't need the body of the if statement. We'll say change state to our aggro state. And when we toggle aggro off, we'll change state just to idle. All right, and not toggle aggro. Ooh. Is aggro. Tried to use a function as a variable there. We'll go ahead and save that. Next up, we now have this where we can toggle aggro on and off. I haven't written the actual following code yet. And there's chat. Technically, you could if it was an accessor. Yes, I could. I couldn't call it as I could use a function as a delegate, but yeah, definitely wasn't what I was looking for there. But we do now have this function. It's going to turn that on, change to the state, or change to the idle state based on whether we turn this on or off. So not our lamp. I want to go to our player script, which I thought I had that open. Not our player, our aggro. Right, I'm writing it as a separate script. So our aggro, we don't need any starter update to run for this. This is only going to care about those trigger messages. When it detects a collision, we don't necessarily want to try and aggro everything it detects a collision with. We're going to want to check if the other object has a specific component. And that component we're looking for is our guard script, or in this case, we've called it nav agent state machine underscore best. We'll try and get that component. We'll go ahead and store this in a local variable, and we'll call it agent script. Because get component does not always return a component. So for example, if we hit one of the nav points, it will run this code. It'll try and get a component called nav agent state machine best from one of those nav points. It won't have it, so it will just set this to null. That gives us the ability to use an if check to see if agent script is not equal to null. We know that we're actually colliding with an agent here. So if it does have that agent script, we can then use the agent script. Agent script dot, and we have direct access to any of the functions in there that are public. And I don't care about the Git components. We've created one called toggle aggro. For our on trigger exit, it's going to be doing that same exact thing. So I'm going to just copy that, paste it down here, save this. And even though it won't follow yet, it should be changing the state to aggro, and we should see that color change. So let's check this out. When we press play, got to get within the range. We see it's now magenta, so it is actually changing to that state. That state still does nothing. We're going to have to change that so it actually chases our player. So interesting thing though, we need our nav agent state machine to know about our player's position. So there's a couple of things we could do. We could say, we could pass in our player object here so that we can store a reference, or we can find the object, except with this method, the enemy will aggro through walls. Yes, it will. So I'm not showing, there's another video that goes through the other ray trace check to see if it is actually hitting directly or there's something in the way. I'm not too worried about that. You can look into that one if you want to toggle the aggro on or off based on that. But for this one, I'm just going to show like how to get the aggro set up. Earlier, toggle for distance. Sorry, I just want to read through this a little bit. Yeah. So we will need to know about our player's position and stuff. So there's a couple of things we can do. We could hack it in here so that our aggro state is the only thing that knows about it. We'll go ahead and create a variable of our player. We'll just use the suggested name, lowercase player. Initialize it to null. And then when we enter, we'll go ahead and set our player object or our player reference. We'll just find it when it first enters. Game object dot find. And we could search with tags. I personally prefer doing find object of type. And we'll go ahead and just look for our player object. So this works perfectly fine since we know there's only one player and we don't need to care about multiple players running around. So we've got that finding the player object. We then need to tell our agent to move to that player's location. Well, enter just gets called when it first enters this state. So that's when that collision first happens. I would want to do it every frame because our player can be moving around. It's not just going to be in that same exact position that our character first walked into. So we have another function to override. Override our execute. And that is the one that runs per frame. So while the game's running, it's going to be running this code. Here's where we can tell our actual guard, which we can get from our nav agent state machine helper function. We need to get the nav mesh agent component. Get component, nav mesh agent. And I could have written a helper function to get this to shorten this up, but it's going to be just one instance of it. So I don't really need to worry about that too much. Set destination. And we can specify a vector3 for where we want it to move. So we'll go ahead and set that position to our player transform position. All right. We'll save that. And now, when we play, character's moving, I think, at the same speed, so anyone that aggro's probably be able to keep, oh, no, I'm moving a little bit faster. Okay, I can get away. But they'll aggro, they'll follow until I get just far enough away that they'll continue to the last spot they saw me, and then just go back to their normal patrols. I think I saw in the comment that you said when they hit one of the nav points, they stopped aggroing. That can happen based on what our guard is set up to do for on trigger enter. So I had already added this in during one of the lectures to make sure that if we're hitting one of the nav points, we want to check that the nav point we are hitting is the one we're trying to get to, and that it is currently in our patrol state before it tries to change to idle. So depending on how you set up your other ifs, if we wanted to set up so that our guards respond to that rather than having our aggro script tell the guards to switch to change the state, we could say if our other game object is that aggro type, we can then do our code to switch to the aggro here. We would also have to handle the exit here. Oh, that would move it off our aggro script. So our aggro script would be nothing, and it would just act kind of like a nav point does. Our nav point script is literally empty. It's just there so that we can find that component and find out what type of object it is. Did that clear that up for you about what you were asking? Awesome. Were there any other questions that you guys had today, or? You're good?
Just an unrelated question, more about efficiency. So in Unreal Engine, some people have said that blueprints take more processing power and can slow down the game in general as compared to running C++. Is that more about the blueprint's structure, or is that legitimate across the board?
Blueprints get virtualized and compile like during runtime. There is a way to nativize those blueprints where they get converted to C++ code. But for the most part, unless you're working on a game that has a bunch of items in it, do not worry about it until it starts causing a slowdown. And there are probably things still inside those blueprints that you can just do a little bit cleaner to make sure that they're not taking up a massive amount of processing time. That's always a tough question to ask because optimization really comes down to do not even worry about it until you start noticing a bottleneck. And then you just have to narrow down where that bottleneck is happening and come up with a specific solution for that scenario.
All right, gotcha.
And Adrian, you want me to go over the alarm? Alrighty. We'll go ahead and do that. So our alarm, well, let's go ahead and add an object for that. I'm going to create just let's see, we've used most of these. Now let's just do a cube. And we'll set that in our bottom left corner. Oof. I forget the scale of everything's huge in this level. So we'll scale our cube up so it's a little bit more noticeable. 2, 2, and 2. And just as a quick thing, we'll go ahead and create a material so we can make it a different color. Material, we'll go red for the alarm. And we want to apply that to our alarm. which we've just left as the default name of cube. I do that too often, so I'm going to rename it. Alarm, and even our material, we'll go ahead and rename that one. Alarm mats, and I did not save the color. Alarm mat should be red, yeah. All right, so we've got an alarm cube over here. We need, similar to our navpoint script, where we're just going to create a new script so that we can identify what type of object this is. I don't ever like checking anything by name. It's much easier to just create a script and have a class associated with that. Script alarm node. I want to make sure that our alarm node script is attached to our alarm object. One last thing, I want to make sure that we are running a box collider so that we can, our is trigger on our box collider so that we can detect those on trigger enter messages when one of the guards reaches the alarm. We then need to add some functionality to our agent to let it know to go to the alarm when we press a button. And this was left over just as the example of if we wanted to move our aggro code here, we could. I'm going to leave it on our aggro script. But we got to add a couple of things to this. So just like our toggle aggro and even our aggro state, we're going to need another state down here. I'm going to just copy our pause state since this one will only care about an enter. Our pause state, this will be our alarmed state, or I think they call that one angry. So we'll go angry state. When we enter this, color was supposed to be set to red. And then we need to tell it to move to alarm. So here's where one of these helper functions can come in quite handy. We'll create another function on our guard. So up here, even right next to our other toggles and stuff, we'll say, we'll create a public function, public void, no return type, and this will be called go to alarm. Now, for this, we'll get a reference to our, just like we have it going to the different different points up here, we will need to get our nav mesh agent, tell it to set a destination when we tell it to go to an alarm. Now, where we want that destination to be, well, we're going to need an object to actually track for this. I'm going to go ahead and make this a serialized field so I can change it in the editor per guard. So serialize this field. And this will be just a simple game object. Or I could even set it up as type of alarm node so that when we're looking for it in the editor, it just shows all the alarms that we can select. And we'll call it lowercase alarm, initialize to null so we don't get any warnings. And then down here, we can use that to get its transforms position. All right, so we have this function that we can tell it to go to an alarm. So down in the alarm entry state, we will call that function for our guard. State machine. go to alarm. All right. Now, we need a way to actually turn this on or off. I could set up another bool example of where we check a bool, turn that bool, or flip the bool, things like that. In fact, we'll just go ahead and do that. That'll be a little bit cleaner than another way. So just basically following the same steps we're doing here. We'll create a bool for is alarmed. Initialize it to false. Create a helper function for our manager to actually call. We'll say void toggle alarmed. We'll go ahead and toggle the bool. Is aggro, oh, not aggro, I'm just copying straight above, is alarmed equals not whatever the current value is of is alarmed. And we can check the bool if we are alarmed. We'll change that state to alarmed state. Did I not? What did I call it? Oh, I called it angry. Angry state. Otherwise, and I forgot semicolon. Ugh. We'll just change to idle. All right. I need to make sure that we add the angry state to the machine so it knows about it. Add state, angry state. Okie dokie. And then we need to have our manager when we press, I believe it was on button 3. So we'll open up our nav agent manager. When we're checking for our inputs, we want to make sure we don't put an input inside an input check already. So we want to make sure we are at that same level of checks, these ifs over here. We'll add another if. If we do an input of get key down, key code, alpha 3. We want to make sure that we do the same kind of error checking we have up here. We don't want to be able to press 3 until 1 is at least selected. So we will copy that. We then want to tell our current selected agent, instead of pause, we will be toggling alarmed. Compile that. And when we go to check this out, one thing I want to make sure of is that when we select things, we'll just go ahead and select one of these guards. When I press right, not page down, which whatever, we've got one selected. If I press 3 right now, and we have our game, we are getting a null reference exception. So it changed to red and all of a sudden lit up null reference. It's letting us know it got a null reference somewhere on this line. Something was not set. And that's because we never told our alarm null to be, or our alarm node to be set anywhere. We created a serialized field for it. Got to make sure to assign it in the editor if we're doing that. So we'll stop playing. I'm going to go ahead and select. We'll actually do this a couple of ways. I'm going to duplicate our alarm so we have two different alarms, one for each room since we do have the two separate rooms. I'm going to put these in the room so that they're pretty much grouped with all the other objects. I'm going to select each one of these nav agents in room 1. Not the nav points. Nav agents. When we have them selected, we can do multi-select so it changes all 3 of them at once. We'll tell them to go to the alarm from room 1, our guards in room 2, or room 1 parentheses 1. We'll be going to our alarm parentheses 1. So now that we have those set, we can play and we can go ahead and press 3. We've aggroed the guard that we have selected. It's going through. It's going to go ahead and hit the alarm. And right now, until I press that key, it's not going to do anything. But ideally, when it hits the alarm, it's going to shut off the alarm, then just go back to its normal patrol route. We need to handle that. If we stop playing, when our guard is hitting something, that's our on trigger enter. We are currently checking if it hits a nav point, but we also want to check if it hits one of those alarm nodes. If it does hit an alarm node, and its current state in the aggro or angry state, because we don't want it to be chasing our player, then hit one of the alarms and stop chasing our player unless it was actively going to the alarm. Then, so guaranteeing that it did hit an alarm and is actually trying to hit an alarm because it's in the angry state, we'll go ahead and tell it to switch back to idle. All right, and let me change my camera here. Where did I put my camera? Let's bump this up a bit more. 17, we'll go 25, so that we can see a bit more of that area. And we'll throw our second room's alarm over here so we can see both of them in the gameplay window and the scene window at the same time. If we play this, our player, I'm going to just move over and, well, I don't want the bottom left corner. We'll go up here kind of in the middle between these two rooms so we can still see everything. I'm then going to press 1 here. We've got our very first guard selected from that first room. I just told it to go angry by pressing 3. I'm going to select something from our other room, which I did not add my other guards to our manager, so I can't select anything from the other room. Darn it. But we see our guard. When I do anger it, it goes to the alarm, hits the alarm, then it goes back to its normal patrol. And just the very last thing, our agent manager. I can go ahead and add our other guards to this. Oh, and they're all named the same. That's such a pain. into this one. We'll actually name it nav agent 3, nav agent 4, and nav agent 5. So our second room didn't have had the same names as our first one, making it pretty hard to select from that list. Now they'll be a bit easier to select those other guards. All right. And now we select a guard from that first room, this guy right here. Anger it by pressing 3. We'll go over to our other room, anger that guard by pressing 3, and we see they are going to their specific nav points. And that one guard ended up seeing me after he got out of that idle, or got out of the angry state, and is now pushing into me because he's trying to get to my exact location inside the center of that character. Alrighty. Any questions, or did that clear everything up for you about the alarm and pursue, things like that? Missed a few things while I was explaining, or when you were first attempting it? Okay. Well, other than that, that's pretty much it for this lecture as well as this class. I wish you guys good luck in your future courses, and I hope you enjoy this bit of time off in between your next class and things like that. As always, feel free to reach out to me on Discord or on FSO for anything. Hope you guys have a great time.